Okay, well, look, good afternoon, everybody. Louis given me an introduction, but I think he was still on mute, so I'm not sure we all heard it. Thank you for joining us. My name's Simon Trenerry. I'm a member of the technical team here at Safeguard, and it's my privilege to talk to you all today about dealing with dampness in buildings. Now, just at the outset, so you all know where we're going with this presentation, this is a general overview covering all the main forms of dampness found in buildings, how to identify them, and how to resolve them. It is very much a generalist overview. I'm going to try and keep to the hour allotted for this, so we've got a lot to go through. So thank you all for joining, and I'm going to make a start now. Right, firstly, let's just tell you a little bit about us. We are Safeguard Europe Limited, established in 1983, and we are manufacturers and distributors of products specifically for damp proofing, structural waterproofing, which is below ground waterproofing, structural repair, and timber preservation. They're our specialities, and we stick to those. Sorry, jumped slide there. Right, with a market leader in the UK, we tend to lead the way and others tend to follow. We've been first to market with a number of our products. We've got a team of 5 research scientists on our staff. So these are products designed, the vast majority of our products are designed and manufactured in Britain. So we are a 100% British company, privately owned, so there's no foreign shareholders. And so you've got confidence supporting a British company. Incidentally, we're based in West Sussex, which is unusual for a manufacturing company. Where we do have manufacturing in the UK, it tends to be based in the north, so we are unusual. In the past, we've collaborated with a number of universities on research collaborations, testing out waterproofing products in various scenarios and uses, and we currently export globally. Our global export market is growing quite significantly as climate change starts to affect areas of the planet such as Africa, Australia, Pakistan. I'm sure we're all aware of the floods they suffered with last year. So we've got new markets, countries and applications that traditionally didn't struggle with waterproofing are now starting to experience issues, and that's down to climate change, as well as, of course, issues happening in the UK that didn't traditionally happen. We manufacture a number of ranges, so if you've ever come across any of these ranges of products, these are all ours. Right, so let's have a little look. What is dampness? Virtually all building materials contain certain trace levels of moisture, even when they're technically dry. So even dry plaster on a wall that's been up for, say, a year or two will still have a very small percentage of moisture, possibly 1%. Timber varies a lot in moisture, whether it's indoors, outdoors, whether it's treated, etc. Broadly, a certain amount of moisture in building materials is not an issue, and they're designed for that. However, when it reaches a certain point, it starts to cause structural and decorative damage, and in turn can also cause health issues for occupants of properties affected by dampness, and that's what we're going to be looking into today. So dampness is defined as occurring when moisture becomes visible or causes damage to the elements of a building. So what does it look like? Discoloration and staining of finishes. You can see in this slide, you've got mold on those walls, you've got spoilings for decorative finishes. You can see the paint's coming away, the skirting board's rotten, there's mold on that, and undoubtedly mold and damage to the floor as well. So that's typical of dampness. Pooling of dampness, this is condensation, pooling of moisture, forming of moisture on the surface, absorbing into surfaces. I mean, that can often lead to a growth of mold on surfaces. Obviously, this is an extreme example in this slide, but it can lead to that. Can also lead to damage. Even brickwork is not immune to damage by water. Bricks get sodden. If that can then lead to frost damage as the moisture freezes and causes spalling, or also salts, which are transmitted in rising damp in particular, can also cause physical damage to building materials. And of course, dampness can cause deterioration to the building fabric. Where timber's concerned, can lead to rots, and the presence of rots often in itself is an indicator of the presence of wood-boring insects, commonly referred to as woodworm. There is no one specific woodworm, it's a group of insects that are broadly colloquially called woodworm. So why treat dampness? A number of reasons, practical reasons to rectify and address all of the problems described on the previous slides, but also there's legislation, so there's law behind this and regulatory guidelines. The Building Regulations Part C, which covers how buildings are built, Housing Act, Decent Homes Standard, Homes Fitness for Human Habitation Act, all are all legislation or regulatory guidelines that govern the living conditions within properties, particularly rented properties. Most of the legislation is towards rented properties, but there's also legislation that covers properties generally. And the Housing Ombudsman, which is the parent body for the social housing sector, brought out a report back in 2021, Spotlight on Damp and Mould, which was a groundbreaking report and really set some strong guidelines for social housing providers on the services they need to provide and how they need to deal with tenants that are experiencing dampness and mould in their properties. So there's a lot of reasons to deal with dampness and mould, and we need to take it very seriously. Another good reason, energy saving. Damp building components, and by components we're talking about the fabric of the building, bricks, blocks, etc., plaster, they're poor insulators. Wet walls conduct twice as much heat as dry walls. So we're all trying to save energy. We're all finding the rising costs of energy is hurting our pockets. What can we do about it? Well, by keeping our buildings drier, less energy will go out through the walls, therefore we'll spend less on heating. It is a fairly simple equation in theory. Obviously it takes work to get there. So let's look now at the three main causes of dampness found in buildings. Now, there's a principle to bear in mind when looking at dampness. The key to dealing with dampness is the correct identification of the cause. So we always encourage a principle which is followed by many contractors and industry professionals as a three-step process. Identify the cause of the dampness, deal with the cause of the dampness, then deal with remedial treatments, replastering, redecorating, etc. Sometimes people don't understand this. They see dampness and straight away they replaster, for example, and then the dampness comes back. It's because they're unaware or haven't followed this principle. So it is an important principle and would always encourage people to bear it in mind and follow it. So three main causes of dampness: condensation, the most common form of dampness. I think we've all seen it at some time or another in our cars, or more likely in our houses, particularly recently. This is actually my house. This is one of the rooms in my house. I've got double glazing. It's not even a year old. It's a 1980s house, well ventilated, reasonably well insulated, and yet even in my property, with only a couple of us living there, we get condensation. Obviously, depending on the property, it can be a lot worse, and it needs managing, or at least being aware of. Penetrating damp, very common form of dampness. Dampness comes in through the structure of the building, either through the walls or through the ceiling, and causes damage to the building. And then, of course, rising damp, which I'm sure many of us have heard of. We're going to explore these in a little bit more detail now. So firstly, let's look at tools for diagnosing dampness. The first tools are the most obvious. Use your senses, use your eyes, and use your nose. Externally, there's a lot of vectors for dampness. Through the roof, missing tiles, damaged slates, damaged valleys, chimneys, a big vector for moisture. Obviously, chimneys often out of sight, out of mind, highest point of the roof, so they are exposed to a lot of weathering, and moisture can come in through those, through the pointing, through the chimney pots themselves, for the flaunching. Moisture can also enter a property through the walls, through defective render, cracks in the brickwork, around windows and doors, flat roofs, particularly where you've got abutments onto the main building, common weak points that can lead to moisture entering the building. Lower down at ground level, raised flower beds, raised ground levels externally due to paving, even something as straightforward as a plant up against the wall can prevent a wall drying out, can trap moisture, and then lead to moisture entering the property. So the first step, if you've got any concerns about dampness, is go outside the building, have a good look round, see what you can spot. Internally, there are often clues as well. Obviously, the first one you tend to see internally will be decorative damage, peeling or blistering paintwork, can also be skirting, but often you notice a smell. Often inside, obviously outside smells get blown away by air movement, but inside, because you're in an enclosed area, often a damp, musty smell is the first indication of dampness, particularly if you've got rising or penetrating damp. You can also use tools to help you. Moisture meters are commonly used to investigate all three kinds of dampness. Now, moisture meters are technically designed for detecting moisture in wood, but you can use them in other applications. Admittedly, if you use them on brickwork, on plaster, on paint, etc., then the readings they give are indicative, but you can still use those to build up a pattern of the dampness, which can often help with identification. And if you're dealing with moisture, with timber, they can give you an accurate reading on the levels of dampness, which then lets you know if you need to take action. So let's look in detail at the three main causes of dampness. So we'll start with condensation. Again, here's a picture of another window. I'm pleased to say this isn't in my house. A lot of condensation here, and it's obviously been left. There's a lot of mold growing on that window frame and on the sill. So let's look at what is condensation. As I mentioned, most common form of dampness in buildings. Broadly, warm air, which you typically get inside a building, that can hold more moisture than cold air. When that warm, moist air comes in contact with a cold surface, such as a cold window, it's cold outside, your house is warmed, middle of winter, it's a cold night outside, you've got warm, moist air in your house, that air then cools, that reduces its ability to contain moisture, and that moisture is then deposited on surfaces as a liquid. If it's an impervious surface, it forms as drops, and if it's an absorbent surface, such as plaster, perhaps timber, then it can be absorbed and can lead to damage. This condensation, obviously, most properties will suffer from it at some time or another, but it's a problem that's actually getting worse, simply because as we insulate our buildings better, which is something we're all keen to do, to prevent energy loss, reduce our impact on the environment, and of course save us money, and because modern buildings are designed to be more airtight, this is great in many ways, but of course this reduces air movement in and out of a property, and then leads to the air getting warmer and carrying more moisture. And then if it does encounter a cold surface, such as an uninsulated external wall, cold window, etc., then that can lead to deposition and condensation. So condensation is actually becoming worse in modern houses rather than better, typically, of course. So where does this moisture come from in properties? Well, when a new house is constructed, estimates are 4,000 litres of water are typically used when building a house. You've got water in the mortar, water in plaster, water in many elements of the house, which then takes time to dry off, which is when builders finish constructing a new house. They typically leave it for a few months to breathe, to dry out before the new owners are able to move in. But in existing houses, we all produce moisture simply by breathing. So even when you're asleep, you're producing moisture, comes out through your pores, comes out in your breath. And of course, when you carry out normal human activities such as cooking, bathing, drying your washing, all the normal things we do as people, all of which create moisture. And also don't forget, in this day and age, many of us are living with more people in our houses than used to be. You've got extended families, you've got different generations living in, maybe grannies come to live with you, we've got houses of multiple occupations, so we've got higher occupancy levels, and of course we've got pets, they're breathing as well. So there's a lot of moisture generated in our properties, which then goes into the air and can lead to condensation. So as I'm sure you'll realise, condensation typically occurs in the cooler months. Why is that? We've got our window shut, we go out less, we crank the heating up, it's cold outside, so we're all indoors, we're all carrying out human activities, generating that moisture, that goes into the warm air in our heated homes, and then when that encounters a cold surface, that can lead to the deposition of condensation. Areas to look for, obviously windows, window sills, those kind of areas, but also where air flows poor, in corners, behind furniture, in cupboards, typical places where condensation forms, and then that can lead to mold growth. So measuring condensation, separate to using a moisture meter, which can detect presence of condensation on surface, but often we can typically see that. If you want to measure where the condensation is in your property and try and get a better grip on it, then there's a couple of tools you can use. Surveyors often use hygrometers, which are handheld devices which measure the water vapour in the air. That's fine up to a point, but a more popular tool for measuring and mapping condensation and working out what's happened when is a data logger, which is a small device. It's fixed either with blue tack, tape, possibly some kind of adhesive into a corner of a home and just left for a while, weeks, possibly a month or two. The idea is it takes periodic readings over a period of time. These readings have been downloaded onto computer software, and then that's used to map graphs similar to the ones in this slide here, which can then be used to plot when the condensation's happening, and plot that in terms of temperatures, humidity, and try and work out what's causing it and why it's happening. And sometimes where there are issues with condensation that people just can't get to the bottom of, data loggers are an ideal tool to identify what's happening and why. So condensation, the formation of condensation itself isn't necessarily a problem, but the water itself, it's very pure water, it's distilled water, but it provides the ideal medium for mold growth, which is a concern for many of us, because not only does it look awful, but it can have a potential impact on human health. So dealing with condensation and mold growth, what can we do about this? Well, in theory, reduce moisture production. Open your windows. Okay, easier said than done, particularly in winter. We don't want our heating to all go straight out the window. Drying clothes outdoors, again, fine in summer, but what can you do in winter? You need to drive them indoors. Vent your tumble dryer outside. If you've got one, that's fine. If you've got an outside wall to vent it through. Use of gas and electric cookers, okay, but you've got to cook. Extractor fans, great if you've got one fitted, not every property has. And again, keeping trickle vents open can help to get that damp, moist air outside if you've got trickle vents. So these are great solutions in theory. Whether they're practical, well, that's debatable, but certainly it's worth bearing in mind they are, in theory, simple and cheap ways to deal with condensation. Increasing the air temperature, again, in theory, by keeping the air consistently warm, you will keep that air, it will still have the ability to carry that moisture and be less chance of it being deposited on surfaces condensation. Again, fine in theory, but when we're all finding the cost of heating our homes is hurting our pockets more and more, we may not have the ability to do this. So again, this is another solution that is great in theory. Whether it's practically possible depends on our individual circumstances. Using dehumidifiers to treat condensation. This is one solution, but again, it's another one where perhaps it's better as a theoretical solution than a practical solution. It deals with the symptoms of a condensation only by reducing the moisture load in the air, but with high running costs, they use electricity. They're quite bulky. They can take up a lot of space, you know, depending on the size of your property, might not be something you can deal with, and they can be noisy to run. And typically they run at night when you're trying to sleep. So again, this is a solution, not necessarily practical. Improving ventilation, this can help. If you've got air bricks, make sure they're unblocked. If you've got trickle vents, leave them open, though in all fairness, along with the air going out, you will lose a certain amount of heat. If you've got an extractor fan fitted, consider changing it. If it's a traditional timer extractor fan that runs for a few minutes after you've turned the light on in the kitchen or bathroom or wherever you've got it located, that's fine, but when the timer switches off, that won't necessarily have set the humidity to where you want it to be. So consider replacing that with a humidistat fan, which is a fan with a sensor, and it simply detects humidity to a certain level that you set when the fan's installed, and it just runs as needed. These are very useful. Or positive pressure units. These are very popular over in Europe and are increasingly being fitted to new properties. Not so easy to fit them to existing property because they're fitted in a loft. So if you've got a loft conversion, you're going to struggle to find somewhere to fit the fans. And they also use ducting to move air around your property. What they do is they bring air in from the outside, force it around your property. The idea is to encourage air movement and try and get some of that warm, moist air outside without it coming into contact with the cold surface. So they're great in theory, but as retrofit, not necessarily so practical because the ducting's got to be run somewhere, so it can involve taking ceilings down or floorboards up. Not necessarily practical for every property. And as I mentioned earlier, it depends on whether you've got space in the loft. But basically, we work on the principle moving out warm, moist air outside before it's got a chance to condense on a surface. So preventative measures, taking all of the previous solutions into account. So you can't reduce moisture production. Keeping your heating up isn't necessarily practical from an affordability perspective. You might not be in a position to fit or change an extractor fan. You might not be in a position to run a dehumidifier. What else can you do? You've got condensation forming in your property. You know it's happening. What solutions can you apply other than that? You can use anti-condensation paint. paint. These are a version of emulsion paints, but they've got small glass spheres in them, which slightly increases the temperature of the surface the paint is applied to and reduces the risk of condensation forming. Drawback with these, the paint has a rough surface to it. The glass spheres don't give the paint the usual smooth surface we're used to. Some people don't like that. Only comes in a limited range of colours, so it may not be suited for every property, because you might not want your house in magnolia or white or whatever. And also it makes a small difference, but depending on the severity of the condensation issue, it might not be enough to deal with it. So it's one solution, typically used in small problem areas. If you've got a corner of a cupboard, corner of a room that's prone to condensation, and just one small area, this is a great solution. It's not often used on a larger area, as in whole rooms. A more popular solution is anti-mold paint. So mold resistant paint. So these are normal emulsion paints that are used in the same way as any other emulsion on a wall, but they've got a biocide in them. They come in two forms. We supply them ready mix, so precise amounts of biocide are applied to specific paints that we supply, and they will stop the appearance of black mold for up to 5 years. So condensation can still potentially form on the walls for the painting of these paints, but because of the biocide, no mold will form. Drawback with these pre-made paints is limited range of colours. So if you particularly want a specific colour, a particular brand type of paint, obviously we know there's lots of decorating suppliers out there. They do thousands of different colours and types of paint, and you might want something that isn't covered in our range, then anti-mold additive is the solution. It's a simple additives mixed in with whichever emulsion paint you choose to use, and it's a biocide again, and it gives up to 3 years worth of protection. Now, 3 years, typically, or quite often, people redecorate after 3 years anyway, so 3 years protection is often enough. And these solutions are really, really popular. Both of these are really popular with landlords, both private and social sector landlords, simply because they can be applied between tenants. And for a landlord's perspective, it removes any concern about mold forming. So you've carried out your responsibilities, your due diligence, and it means you're going to have less concerns about decorative spoiling at the end of a tenancy. And of course, tenants like them because if these are applied, then they've not got to worry about mold formation through their normal activities, cooking, washing, etc. So these are popular solutions, and incidentally relatively inexpensive. Anti-mold sealant, I'm sure we've all seen these, and I'm sure many of us use them, but when you're having decorative work carried out, new bathroom fitted, new kitchen fitted, new loo, whatever, use of an anti-mold sealant. So again, it's a standard silicon sealant, but it's got a biocide in it. It stops mold forming, because I'm sure we've all seen, if you use standard silicon sealants, you can get black mold forming on those very, very quickly after they've been installed. Another solution to deal with mold is removing the mold itself. Traditionally, people used to just wipe the mold away or use bleach. Unfortunately, mold, think of it in terms of a plant. So there's the black mold you see, but it's also got roots. So if you use just warm water, soapy water, or if you use bleach, all you're doing is taking the mold off at the top. You're leaving the roots in there, which grow back very, very quickly. And in fact, when you're wiping it in that fashion, then you're actually spreading the mold, and typically the mold problem actually gets worse when you've used those solutions. So the modern solution is use a two-step product, a mold eliminator and sanitizer. So effectively, you spray the mold eliminator on, leave it a few minutes to work, wipe it off, spray the sanitizer on, leave it a few minutes to work, then wipe it off, give the surface a good wipe over. So you've killed the mold, you've removed it, you've killed it. And then if you paint over with a mold resistant paint, the ones we've just discussed, then you've got a nice brand new surface, and it's mold resistant, prevent the formation of mold. So again, really popular solution where you've got, for example, mold on your bathroom ceiling. Apply this, again, all inexpensive products, easily applied, and they do a great job. Very well worth considering. Right, I've covered a lot of this, but incidentally, the mold eliminator and sanitizer, we supply it in a couple of forms. Small handy spray bottles that can be used by anybody, keep them in your bathroom, have them at hand, but we also now supply in larger commercial packs. This is aimed at, for example, social landlords. You might be a housing association with 5,000 properties, and you want to go around and treat all your properties over the winter. We supply in large bottles, large containers with sprayers, so it can be used by teams carrying out maintenance work. That's very popular, particularly with commercial customers of ours. Improving surface temperature. Another solution to deal with condensation, obviously warm air containing moisture reaches a cold surface and then forms as condensation, which can lead to mold. Depending on the structure of your building, if you've got solid walls in an older property, if you've got a modern extension, it's just been built with blocks, often they can have very cold surfaces, and the moist air, when it reaches those surfaces, can lead to condensation issues. And this is quite common. There's millions of solid wall properties in Britain, and also there's plenty of modern extensions that are just built with single skin walls, and those walls cannot be as warm as we'd like them to be, and that can lead to formation of condensation. So what can you do about it? External wall insulation is one solution, but there's many reasons why that's challenging, which is why it's a rarely seen solution. Solid walls or single skin walls, there's no cavity to fit cavity insulation in. So your next solution is look at internal wall insulation. Challenge with internal wall insulation is typically it's quite thick, so you apply it to the wall, but it reduces the space in the room. That might not be desirable depending on what you've got in the room, what you use it for, how big the room is in the first place. Affecting that space by applying insulation might be something you simply can't live with. So for modern solutions, we supply two separate kinds of internal wall insulation that are very thin, 10 to 12 mil thick. So you're talking half an inch, give or take, which is really thin by the time it's applied to the wall. Yes, it's going to have a plaster skim over the top, which will add another few mil, but typically that's at least half of similar performing conventional insulation, which can make a big difference. When it's applied around all four walls in the room, makes a big difference. What does this insulation do? Significantly reduces heat loss through the wall and provides a warmer surface. So it reduces the likelihood of condensation forming and keeps the room warmer, because less heat will be used or will be lost through the wall. And these are typically used in conjunction with storm dry masonry cream, so not only keep the wall drier, but if you do have a cavity wall, it also reduces the potential for interstitial condensation. So EP board, this is one of the two insulations we do that are of this type of thin insulation. Easy to install. It's basically adhered to the wall using adhesive. Saves space. It's also breathable. So again, it doesn't reduce the wall's ability for moisture transfer. Just to give you an idea on this slide, we show comparing insulation performance. It shows the difference where EP board would compare with more conventional forms of insulation. So depending on which type of insulation, PIR, PUR board, which is a commonly formats for rigid insulation, or often it's a yellowish amber color. You'd have to go to virtually double the thickness to perform the same as EP board. Polystyrene, less used these days, but it was very popular back in the 70s. And obviously polystyrene is still commonly used in cavity wall insulation. You'd need even thicker amount of that to provide the same performance. And then when you get to mineral wool insulation, which you typically use in the loft, you've got to go to nearly 2.5 times the thickness. So it shows how well these types of insulations perform. They make a big difference. However, there is a trade-off. Per square meter, these kind of insulations are more expensive than the thicker ones. So you could argue you pay your money, you take your choice. But if space is your primary goal as well as heat saving, then these are very well worth considering, and they do a great job at reducing the likelihood of a formation of condensation. Our other version of this is ultra firm, which again is similar to EP board in that it's adhered to the wall, creates a warmer surface, cuts down energy loss, doesn't perform to quite the same high level as EP board. So really you're better off considering this more as a solution just to help prevent the formation of condensation. So if you've got, for example, a wall or a room that's particularly prone to condensation forming on the walls, maybe it's a north facing or coastal facing wall, single skin, a lot of issues in there with condensation forming. This is worth looking at as a solution to that. Another solution you can use is external waterproofing. This contributes to warmer internal surfaces because dry walls transmit less thermal energy than wet walls. So if you can keep that wall dry by applying a waterproofer, that wall will then transmit less thermal energy. The inner face of the wall will be warmer and you'll lose less heat through it. So again, this is a very popular solution. Okay, let's look at penetrating damp now. So, as I mentioned earlier, penetrating damp can come in through the roof or can come in through walls. Roofs, we don't get involved in roofs other than in relation to chimneys, so we won't cover roofs, but it's just worth bearing in mind that roofs generally are one vector for penetrating damp, but typically it's more likely to enter through the walls anyway, and it can enter through single or cavity skin walls, can come in through the wall ties or through cavity wall insulation, which we're going to look at now. So, typical symptoms of penetrating damp patches on walls, decorative spoiling. Here you can see paint and papers coming away. Guessing this is a converted loft looking at this slide, but you can see the damage from dampness coming through the walls, and this can happen quite quickly, particularly with penetrating damp, where you can have large amounts of moisture coming through a wall from wind-driven rain, and again, particularly these days where we get heavier rain than we used to. And then paint blistering. If you've got a painted wall, that moisture comes through, it comes in behind the paint, makes the paint delaminate and eventually fall apart, leads to blistering and damaged paint generally. Just bear with me a second, please. I'm just going to grab a mouthful of water. Fantastic. Okay. Greening mortar joints. This isn't commonly seen, but it's worth bearing in mind. Moisture comes in through the walls, it follows the path of least resistance, which is often the mortar course, and in this case it's come through. It's created dampness, literally traced the line of the mortar, and that's led to mould formation. And this is called grinning mortar joints, but it's another symptom of penetrating damp. This one's particularly bad in this particular slide. Circular spotting and blotches. This is a plasterboarded wall. As I'm sure you're all aware, when plasterboard is typically applied, the dot and dab method is used. So blobs of adhesive are attached to the back of the plasterboard. Plasterboard's then pressed up against the wall. If penetrating damp comes through from the other side and it meets the adhesive, well, the adhesive, typically a polymer adhesive, is basically waterproof, so the dampness coming in through walls spreads out, goes all around the adhesive and creates these circular blotches which then find their way through the plasterboard. So this is another way penetrating damp can manifest. So let's look at common causes. And incidentally, just to reassure everyone, this presentation isn't a big sell by Safeguard. A lot of the information we're giving you covers products we don't sell and covers solutions that you can apply yourself for zero money. So this isn't a hard sell by us. This is simply us giving you all general information. As in this example, block leaking gutters. Common cause of moisture penetrating into properties. Obviously, we look at our gutters from ground level. We've no idea if they're clogged, if they're working, if they're up to the job. Again, with heavier rainfall these days, as you may be aware, new houses typically are spec now. I think they have to comply with building regs, are spec with deep flow guttering to cope with greater falls of rainfall. But on older properties, we've just got 4.5 inch half round gutter that can not be able to cope with the rain coming off, particularly larger roofs. If that spills down the wall, as in this particular slide, some of that moisture can penetrate into the building, particularly if the mortar isn't in great condition. And here's an example, mortar not being in great condition. Pointing on walls, depending on how the wall's pointed, the age and condition of pointing, this is a very common vector for coming in. In this particular slide, you can see there's some cracking just over there next to pointing. You see some cracking there in the mortar, and that can allow moisture to get into the building. And also the shape of the pointing. Pointing should be either, there's 3 examples here, should be bucket handled, so it's concave, so even wind-driven rain will go in there and run off. If it's flush, it will run off. But recessed pointing, which was very popular in the 70s and 80s, well, that can effectively form a recess, but moisture will sit in, and if it's not blown away by the wind or doesn't evaporate, that can then work its way into the building and lead to penetrating damp happening. Defective flashings, another common cause. Again, a lot of flashings are at high level, abutments from flat roofs, abutments around chimneys, etc. People can often not be aware that where these are chased into the wall, they've come away, or the flashing itself is deteriorating, and this can be a vector for moisture ingress. Holes in walls. Cable entries, you used to have a satellite dish fitted, now you've got cable or something different. That's taken away, but the hole's not filled. Pipes that came through the wall, all kinds of reasons we can have holes in our walls. Old extractor fans that have been removed, but these can be vectors for moisture, so these are worth assessing and dealing with if you've got issues. And faulty window and door seals. Up until the modern day of Double glazing, typically windows were sealed with cement or linseed putty. That doesn't last forever, and even modern sealants don't last forever. When I had my double glazing replaced last year, my double glazing was originally installed in my house when it was built in 1983, and the sealant all around the windows had gone completely brittle. It was actually like mortar. It was so brittle it was cracking. I didn't have moisture ingress, but I could have done. So even with modern windows, it's worth bearing in mind that sealants don't last forever. They are vulnerable to UV and they will eventually break down. So when you're looking for moisture vectors, that's worth considering. Porous masonry is another one. It wasn't uncommon in Victorian times for bricks that were fired for internal use to be used on external walls. So they were vectors for moisture, and obviously bricks can be subject to the effects of weathering, pollution, spalling, which can start to break down the surface. And you may not be aware, bricks are hollow anyway, so they're designed for a certain amount of moisture to penetrate, which then leaves the brick due to weathering and due to the sun. But depending on the condition of the brick, that moisture and the weather conditions outside, that moisture can potentially penetrate to the inside of the property. Cavity walls, another possible vector for penetrating damp. When the wall's built, cavity wall, they use wall ties between the inner and outer skin. Older wall ties didn't have a twist in the middle, so if moisture got in, they could basically act as vectors, flat vectors for moisture to run across. And also when the wall's built, if the bricklayer constructing the wall didn't deal with mortar drips inside, or didn't wipe away the backside of the bricks, then mortar could drop down onto these ties. As we've already explored, mortar is a great conduit for moisture to travel through it. As you can see in this image, you've got a wall tie there. It's covered in mortar and it's effectively acting as a bridge across the cavity. So rain had hit the outside, come through the bricks, and then travel across to the inner skin via that mortar there, and eventually work its way through and cause damp patches in your living room or your bedroom or wherever. Cavity fill insulation. Again, I'm sure we've all heard horror stories about people having issues with this. Cavity insulation is great if you've got a cavity wall. In theory, cavity insulation is a brilliant solution because it does a great job of keeping your property warm, doesn't affect the inside space of the property, doesn't affect the aesthetics of the property, and it's great as long as it stays dry. But if you get a moisture coming through that outside of that brickwork, get into that insulation, then once the insulation's wet, when it's dry, it prevents loss of energy. When it's wet, it actually allows energy, as in thermal energy, from inside to travel outside, and it also acts as a conduit for moisture to come into the inner walls. So that's something to consider as a possible cause of penetrating damp if you're seeing dampness in your property. So what can we do to treat penetrating damp? A lot of the solutions are very straightforward. You can fill holes and voids in brickwork, replace your pointing, and it's a good idea when you're replacing pointing to use a mortar additive. We supply a mortar additive which then makes the mortar waterproof but breathable. It's worth doing. If you've got cracks in the brickwork, repair those using crack stitching kits, replace flashings that have failed. They're all relatively easy, relatively inexpensive solutions. Coatings on the outside of brickwork, these are a little bit of a double-edged sword. If brickwork's painted outside and that paint started to crack and weather, moisture can get in behind that and then cause the paint to delaminate, come away from the surface and start to break up. But that can also trap moisture, which can then penetrate inside. So paints are great and in good condition, but as they start to weather and break down, perhaps they started cracking, so buildings moved in the summer, it's had a lot of sun on it, whatever, mechanical damage perhaps, then they can cause more problems than they save. So, and painting over them only adds to the problem, because if you paint over, say you have this happening on your painted wall, you painted over it, well, you're trapping moisture underneath. That moisture is going to go somewhere and you're going to get problems with the new paint blistering as well, and you're likely to have that moisture still trying to work its way inside. So if you've got damage to external paint, then it's worth replacing, simply taking it all off and replacing it. And much the same applies to render. In this particular image, some concrete render on the wall, which is great, it's a weatherproof and it's new, but you can see there's lots of cracks, and you can see where a hole has formed here, moisture's got behind. You can see this big staining here. So if you just patched up that particular area of a render, all you're doing is trapping moisture. And again, that moisture is going to go one or two ways, probably both. It's going to cause more damage to the existing render and add to the problems of moisture getting in, and some of that's going to track inside. So really your solution there is replace all of the render. A solution you can use for this: If your wall is rendered but not painted, or if it's unrendered, then you can apply a masonry protection cream to waterproof your wall. Now, we reference Storm Dry here, which is our masonry protection cream. As many of you are aware, Storm Dry is the leading masonry protection cream. We're very proud of it. But applying a masonry protectant, it's very common. A lot of people do it. The cheaper ones do a reasonable job, only last for a year or two. Products such as Storm Dry will last for many, many years. Ours has got a BBA certificate for 25 years, but these do a couple of important jobs in your property, and it's worth bearing in mind. Firstly, by waterproofing your wall by applying a masonry protection cream, that stops water penetrating into the brickwork, so reduces the likelihood of any penetrating damp getting through the brickwork. And as we referenced earlier, dry walls transmit less thermal energy, so it keeps your walls warmer inside, reduces the likelihood of condensation forming, and you'll lose less energy through your walls. So there's a lot of good reasons to apply them, and arguably they could be applied to every single wall of every property. Even if you haven't got penetrating damp, we all want to reduce energy loss on our properties, and we all want to prevent penetrating damp. So arguably, even if you bought a brand new house, you could apply a masonry protection product such as Storm Dry to the outside, and there'd be a good reason to do so. Right, let's have a quick look at rising damp. So what is rising damp? We've all heard of it. Not all of us know what it is. It's commonly used, can affect all kinds of properties. It's not limited to older Victorian and Georgian properties, can affect new properties. I've dealt with a technical inquiry from a customer the other day. He's had an extension built on his property 4 or 5 years ago. He's now got rising damp coming in, all kinds of decorative spoiling. It turns out the builder didn't put a damp proof course in the wall. So this property was built, this extension was built, I think 2018, 2019, just around lockdown. And this customer's got rising damp. So it's not a Victorian problem, it's a 21st century problem, and can happen to any problem, every property. So what is rising damp? As I mentioned earlier, bricks and blocks are actually hollow, and due to capillary action, which is a scientifically proven phenomenon, water can travel through very small spaces, and it can travel vertically. So if you imagine, I'm sure it's happened to all of us, we've paddled in the sea, perhaps stood in a puddle, got the bottom of our trousers wet, and that moisture's traveled up our trousers and reached our knees, even if we've only got the bottom of our trousers wet. That's exactly the same principle happens in rising damp. Dampness in the ground, so typically it happens in properties that are where the brickwork or the masonry is at ground level and it's touching a source of moisture such as the ground, and that moisture naturally rises up through the brick and it causes rising damp. So the masonry itself acts as a wick. Protection against this should be a damp proof course that should be fitted in certainly every wall built since 1875, but it's not always the case. So what does it look like? Well, it looks like staining, typically at low level. And when I say at low level, it's rare to see it much above 1 to 1.2 meters, occasionally 1.5. Now, in theory, rising damp can rise to 5 meters. In practical terms, evaporation takes hold and it rarely gets much past the meter. So, and typically, in most properties, it gets up to maybe a meter or so before people do something about it. But here's some examples. Worth bearing in mind as well with rising damp, quite often you see a white salt band at the top. There are naturally occurring in the soil salts, which are minerals in very small quantities. Some are produced by human activities. Some of them have been there since the earth was formed, but they're small amounts of minerals. These get dissolved in water. As the water rises up in the wall, it brings the salts with them. Eventually, some of that moisture evaporates out, which I mentioned a minute ago, but the salts don't evaporate. They end up trapped in the brickwork, leaving behind this white tide mark. So how can you detect rising damp? Well, I mentioned earlier moisture meters, and these are very useful in rising damp for taking indicative readings. So you take readings up the wall, as I mentioned earlier, with these meters. They're designed for use with wood, use in timber, so they give an accurate reading in timber, but when you use them on other surfaces such as a plaster wall, such as brickwork, they give an indicative reading. So for example, if you used a meter and it said 90 or 70, it doesn't mean you've got your wall is 90 or 70% wet. It means it's very wet, but you treat them as indicative and you use random readings taken across the wall to build up a picture of where the dampness is, and that then gives you a guide for where you need to treat. I mentioned this earlier, so moisture in the ground contains salts, and these salts accumulate over time in walls affected by rising damp. Typically, they'll form towards the top of the rising damp, and they're quite obvious and often seen on brickwork, or when you take plaster off walls, then you'll see them behind, but they can also come through to the plaster. So, rising damp. Is it rising damp coming up through the wall, or is there actually a DPC present that's bridged? Now, there are a number of ways that an existing damp-proof course can be bridged, and it's surprisingly common. We get lots of technical inquiries from customers who've got rising damp, and the simplest cause is when a DPC is installed, incidentally, on an external wall, it's installed 150 mil above the ground level, so 6 inches, typically 2, possibly 3 mortar courses above ground level. Of course, what happens over time, we might put in raised flower beds, or more typically, we might pave our drive or put paving around the edge of our property. This raises the ground level, and this can cause the DPC to be bridged. This is quite common. Also, you can sometimes get rubble or mortar from when the wall was built in the cavity, which can bridge the DPC. If you've got a timber wall, the DPC can be bridged due to the construction of a wall, or dirt getting into the cavities. There's a lot of ways that the DPC can be bridged. So if you've got rising damp, lots of ways you can investigate whether you've got a missing DPC or whether there's something simpler you can do, such as raising an exterior ground level. Sorry, reducing an exterior ground level that's been raised. So internally, what can you do to address rising damp? Tanking over the rising damp, or covering up, as it's colloquially known. Often people do this because they don't realise what's happening. Remember, I mentioned earlier the 3-stage principle: identifying the cause, dealing with the cause, and then applying a solution. Well, this is quite common. This is step 3. They see signs of dampness, they don't understand what it is, they don't know what to do about it, but they replaster over the top, repaper over the top, repaint. Totally understandable. But what happens? Well, the dampness hasn't gone away. All you're doing by covering it is hiding it, but it will come through again, either on your newly replastered wall coming straight through. And I've just had a customer contact me in a technical ticket 3 months after applying some replastering, the damp's back. Why was that? Because they didn't understand what they were doing and didn't apply remedial measures. Didn't apply a solution before applying remedial measures. Or in this example, where you can see on this slide, where it looks like plasterboard's been applied to the wall over where the dampness is, and that's simply prevented the dampness evaporating, so it's come up behind the plasterboard and appeared over the top. So short-term solutions are a little more than short-term solutions. You're not dealing with a problem and you're not resolving it long-term. So what can you do about it? If you've got a DPC missing, for example, hasn't been built in the property, either an older property or a modern property that was missed out, you can reapply a physical DPC. However, this is very difficult to do. It's got to be done in small sections so that there's no disturbance or potential collapse of the wall. It's noisy, it's difficult to do. If there's party walls involved, then there can be issues around that. And it requires a lot of skill to do. And of course, if you're getting a contractor to do it, it's very expensive because of the time it will take that contractor to do, and it's a skilled job. So in theory, you can retrospectively apply a physical DPC. In practical terms, very rarely done. Chemical DPCs are the more modern solution, and this is the most popular solution for creating a DPC worldwide. Fairly straightforward and easy to do. The first systems that came out in the 60s involved a chemical, as you can see here in this bottle, and it was pumped into a wall using a pump. Typically, the contractor would drill into the brickwork, pump into the wall until the chemical started coming out. Drawback with these older chemicals were often smelly, so it often involved the resident having to move out because of the fumes, particularly if they had health or respiratory issues, children, pets, etc. Required skilled contractors to do it, was time consuming, therefore expensive. And this method worked. It was revolutionary when it first came out in the 60s, but it's been superseded by modern methods such as damp proofing creams. First one was introduced in the year 2000 by us. So We're very proud of this. They're silane siloxane based, so that's effectively the chemicals that are in silicon sealants, for example, very similar chemicals but in a different form. Much simpler system to use. It simply involves holes drilled into the mortar course of a wall, either internally, externally, slightly different methods if you're dealing with a solid or cavity wall, but broadly the damp proofing cream was injected into a wall by an operative using a gun like this, and then the chemicals in the cream dissipate through the mortar course, creating a chemical DPC barrier to stop that dampness rising. Great system, absolutely revolutionary, performs almost as well as a physical DPC. And the benefit with the creams, they're low hazard, there's no fumes, they're not toxic, they're not corset. You can get them on your hands, you'd want to wash them off, you wouldn't want to leave them there for long, but it won't burn you, they won't hurt you. Great system. Still massive seller for us, still very commonly used and copied by many of our competitors. They're great systems. Only drawback perhaps of the system, does require some skill to inject the correct amount of product into the hole. So you can under inject or you can over inject. So it does require some skill and experience to do effectively. So we have come out with an improved version in 2014. It's effectively a Mark II version of the cream. You've got pre-dosed cotton rods. So for about the length of a biro, and you drill a hole in the mortar course, exactly the same as with the cream, and then you simply insert the rod, and then once it's had time, a couple of weeks to dissipate, then you can seal the hole and leave it to carry out its job. The rod is pre-dosed with chemicals in the factory, so as long as you've drilled the hole to the right depth, the right distance from other holes, as long as it's in the right substrate, the chemicals simply dissipate and create a chemical DPC with no more effort required by the installer. And they're really quick and easy to do because it's pre-dosed. You simply push the rod in the hole, job done, move on to the next one. So again, very easy to do. It takes you longer to drill the hole than it does to insert the rod and create the DPC. Very effective system, and worth bearing in mind as well that both the cream that I just referenced and the rods are both BBA approved. So understandably, as consumers, you might be skeptical about some of the claims we make about our products, understandably, but they've been independently tested and certified by the BBA. The BBA certificate's freely available on our website or from the BBA's website. So they're an independent testing body who test construction products in laboratories, and they then produce a report which says the product will do this, this, and this, and it won't do this, this, and this. So for you as a consumer, you can read that and you can take that as read because that's come from an independent testing body. So after creating a chemical DPC, obviously part of the issue with rising damp, you've got the decorative spoiling and you've got the dampness. The decorative spoiling has affected your plaster and your paint, and you need to do something about that. You can't just leave it. Part of creating the chemical DPC anyway, you've got to take the plaster off the wall to be able to inject into the brickwork to the right depth. But also salt contaminated plaster needs to be replaced because there's dampness already in the wall, which will keep coming through onto the plaster. And even when you've created a chemical DPC and stopped dampness rising any further, you've still got dampness in that wall that's still going to want to come out. So unless you want to leave it and leave your wall damaged, stained and damp, you need to do something about it. So British Standard 6576, which is the code of practice for the diagnosis of rising damp in walls and the creation of chemical damp-proof courses. The guidelines within that are that existing plaster should be removed either to 1 metre above the DPC line, often taken to be 1.2 metre above the floor if there isn't a DPC line, or to 300 mil above the highest level at which dampness is detectable. The point here is dampness within plaster isn't always visible. You can map it with a moisture meter, but quite often, just to be on the safe side, people will remove the plaster maybe up to 1.5 meters or possibly the entire wall and replaster it. It's also worth bearing in mind that dampness in that wall contains salts. So if you replaster with standard gypsum plaster, that dampness will come through again, as will the salts, and you'll effectively be back to square one. So there are specific ways of dealing with this, which we're just going to look at now. You can use a traditional replastering system with sand and cement render on the wall. Common practice is to use an additive such as Render Guard Gold, which is mixed in with that render. That blocks the dampness and salts coming through. You'd then skim over with a gypsum coat, and then quite often people apply a mold resistant paint over the top. This is a traditional solution, still used by many people. Couple of drawbacks with it. Obviously, you've got to source the right sand for creating the render in the first place. Obviously, it takes time for all those wet layers to dry out, and the drawback is it doesn't allow the wall to dry out very quickly. So modern, that basically just covers the points I just made. Modern breathable renovation plasters are a favoured solution in many situations these days. These are pre-mixed plasters. All you do is add water. You apply 2 layers straight onto the wall. What these plasters do is they do 2 things. They hold the salts trapped in the dampness back, but the plasters themselves are breathable, so allow that dampness to work through. You then skim over the renovation plasters with a standard gypsum skim coat, which in itself is slightly breathable, but it's enough to allow the moisture in the wall to come through. Now, it's worth bearing in mind, walls take a long time to dry out. Typically, 25 mil of wall, so that's an inch of wall, takes a month to dry out. So if you've got a 240 mil wall, 9-inch wall, that takes a long time to dry out. And obviously, if you don't allow the wall to dry out, and that moisture, chances are it's going to go somewhere else. And again, as we mentioned earlier, with covering up, that dampness could move. So the use of a breathable renovation plaster is to be encouraged, and again, that can be overpainted with a mold resistant emulsion paint, or if you want to use a normal emulsion paint, if you don't feel there's a risk of condensation and mold forming. You can't use vinyl paints, or it's not recommended to use vinyl paints or papers over the top. Why is that? Because they reduce the breathability and you're trapping that moisture in the wall, and that's not good for all the reasons we've just discussed. And again, we've covered all these points a second ago. Other solutions. Sometimes it's not possible or not practical to apply plasters. You've got different layers, they need drying time between layers. It's slow, it's time consuming, it's not always the right solution. Sometimes you need to use plasterboard, particularly if you're in a commercial situation, you're a landlord and you're making good between tenancies, and the longer the property is vacant, that's costing you money. You want to get it back into use quickly. So you want to look at using plasterboard. We have a solution for this. Again, the existing plaster stripped off the wall, and this is assuming, of course, you've created your DPC, etc. And then you use our express system. So this is a 2-stage system. A cream is painted on the wall. It's a breathable cream that holds salts back, so it allows the dampness in the wall to breathe again, holds the salts back, and then you use a special adhesive to fix your plasterboard in the traditional dot and dab way. And then what this does is this allows the wall to breathe. The small gap between the plasterboard and the wall allows the moisture in the wall to come through the dry shell cream, evaporate harmlessly, doesn't reach the plasterboard, so you don't get staining. So again, this is a very popular solution. Sorry, again, I covered those points there. Another solution you can use is a physical membrane. Now, it's not always possible to create a damp-proof course for a variety of reasons. It might be a party wall, for example. You might have dampness on the other side, and for whatever reason, the owner of the wall on the other side might not be in a position to address it, might be unwilling. So applying something like a damp-proof course won't necessarily work. You've got moisture coming through. You might not be able to deal with the ground levels outside. 1,000,001 reasons that might not be the solution. So another solution you can look at is applying a membrane to the wall. So there's a couple of ways of doing this. This particular system is our dry base flex system. So it's a membrane that's adhered to the wall using an adhesive. So you take your existing plaster off the wall, apply the adhesive to the wall, and then the membrane is effectively stuck to it, smoothed out of a trowel as in this image. That then creates an impervious barrier which you can plaster straight onto. This is a great solution. Again, very quick, very popular with commercial customers, but obviously you're not dealing with a problem, you're covering a problem up. Now, sometimes that's the only solution you've got. And again, it's a popular solution, particularly with commercial customers. Low profile, it's very thin, being a membrane, can be applied to damp substrate. So literally you can apply it to a wet wall and you can plaster straight onto it. So if time is really of the essence and you've got to get in and out quickly, this is a great solution. Another solution is a physically fixed membrane. you might prefer, it might be more suitable for the job. There might be previous coatings on the wall that you just can't remove. So applying a membrane like this particular one, Oldroyd XP, this is mechanically fixed onto the wall and then plasterboarded or plastered straight onto. So again, it's a quick and easy system. As quickly as you can get the membrane up, you can get it plastered, and then that plaster will dry out. Only thing to bear in mind as well with both these systems, when you do plaster onto them, because they're going onto an impervious surface, the moisture in the plaster can only go one way into the room, so it will take the plaster longer to dry out. So that's just worth bearing in mind. Okay, we're nearing the end of the presentation. Other forms of dampness, chimney damp. During combustion, when you burn logs in particular, but also with coal, initially it takes the fire a while to catch, and that's moisture cooking off from the logs, but also there is a certain amount of moisture in dry logs and in coal. That moisture also contains salts, slightly different salts to the salts I referenced earlier with rising damp, but those salts can rise up through the chimney stack. They can then form on the interior of the stack, work their way through as that moisture dries out from inside of the stack out, and then those salts are hygroscopic salts, so they can attract moisture in the air, which, as we discussed earlier, is naturally occurring, can lead to damp patches on the surface. Also, chimneys, often out of sight, out of mind. Moisture can come in through uncapped chimneys, cracked brickwork, defective pointing, cracked flaunching. So chimney damp is another specific kind of damp. Obviously, it only happens where you've got a chimney. And worth bearing in mind, incidentally, with chimney damp, that your solution there, because the hygroscopic salts are in the brick, your solution there would be applying a solution such as dry base flex to cover up, go over the surface, because the salts are in the brick, and other than removing the bricks, there isn't a solution there. Or alternatively, if it's externally due to pointing issues, then you can repoint using the solutions we mentioned earlier, and perhaps apply storm dry cream to weatherproof the brickwork, so you're future proofing it against further moisture ingress. And damp floors, this is another kind of dampness. Again, floors aren't always laid with a DPM in the floor, particularly floors pre-First World War often didn't have a DPM in them at all. Then after that, up until the 60s, they often had an asphalt DPM, which doesn't last forever. And even modern houses, again, I had a technical inquiry from a customer the other day, building extension, and the builders forgot to put a DPM in the floor, so his brand new concrete slab is soaking water up, and he's got dampness coming through, and his extension isn't even finished yet. So damp floors are a common problem. If a DPM can be fitted when the floor's built, that's great, but if you can't, then you can retrospectively fit a DPC with a couple of solutions. Our liquid applied DPM is a paint-on product, paint onto a concrete floor prior to adding screeds, underfloor heatings, decorative coatings, etc. Simple paint-on product. Alternatively, if it's more a commercial application, or one that isn't going to be covered by a decorative coating, then you can use an epoxy floor coating. Again, not only acts as DPC, but also acts as a coating. So this is really popular garages, commercial users, commercial kitchens, restaurants, those kind of applications. Being epoxy, obviously you have to take some care mixing it, care applying it, but it provides a hard wearing, long lasting floor. And then another solution to consider is there are actually membranes you can apply on the floor, loose laid membranes onto which you can apply your floor covering, and again these act as a DPM and stop moisture coming up. Right, I'm 3 minutes over, so apologies for that, but thank you all for listening. That's broadly covered all the main kinds of dampness. We have other seminars. If you want to know about these in greater depth, we run other webinars regularly, specifically cover penetrating damp, rising damp and condensation, so they're hour-long seminars on those. We've got another webinar that covers basement waterproofing, so if you're interested in below ground waterproofing, but incidentally I haven't touched on in this presentation at all, because that's a whole world of its own. And then if you're interested in the energy saving side of things, retrofitting insulation, then we've got another webinar that covers the PAS 2035 guidelines and energy retrofit generally. They're all available. You can sign up for those via our website. So I can see a couple of questions coming in, so let's start answering those. So let's have a little look. I just saw a couple coming up. And I've lost both of those actually. Right, sorry, a couple of people wanted to ask questions and I've lost you. So if you'd like to speak up, I'll see if I can help. Nope, I can't hear anyone. Okay, doesn't sound like anyone's got any questions. Okay, well, if you have got questions, please feel free. You can call us. That's our number there. You can email us. If you email us there, if it's a technical question, that will get passed through to myself and my colleagues in the technical team, and we'll answer it. If we don't have the knowledge, then we talk to our colleagues in the lab team. Basically, if we don't know, they're almost guaranteed to know. So between all of us, we've got the answer to most things, and we're here to help. So unless anyone's got any final questions, I think that wraps it up for today. No silence from you all. Brilliant. Okay, well, good. I think we've covered most things. Like I say, if you do have questions, please feel free to come to us. We don't charge for the advice, and as I mentioned earlier, it's not a hard sell. We'd rather give you the right advice, even if that doesn't lead to you buying our products. So thank you all for your time. Have a great day, and yeah, please come to some of our other webinars if you're interested in the subjects we've covered. Thank you all for your time. Thank you. Bye-bye.
Thank you.